Dear colleagues, ladies and gentlemen, we are about to start our blended event, face-to-face combined with the online event, and we are with a slight delay starting this event, which was initiated and is organized by British Embassy in Vilnius, also Research Council of Lithuania and Cormac Consultancy Group. That joint effort is aiming at bringing researchers and academicians from Lithuanian United Kingdom to discuss Lithuanian United Kingdom universities' cooperation in the field of life sciences. My name is Gintautas. I was asked to help to proceed smoothly with this event forward, and I'm director of Cormac Consultancy Group in Central and Eastern Europe. Just before moving on to welcome speeches, I will say that Cormac Consultancy Group is a leading UK organization in the field of internationalization of higher education, and we are working with a large group of UK universities for a number of years, also helping them to establish different types of partnerships within this region as well. So indeed, it is my pleasure to say that we succeeded in such circumstances to make this event happening. We all understand in what international context we all are now working, how concerned we are about the outcome of the invasion against Ukraine from Russian Federation. But nonetheless, we need to get and be able to conduct our daily business, do our best in our fields of responsibilities. Having said that, dear colleagues, I hope that everything across the screen, for those who are online, you can hear us, you can see me, soon you will see more faces, and it is my pleasure to give a floor to His Excellency Mr. Brian Olley, British Ambassador to Lithuania. While Ambassador is taking the floor, I will mention that this was the initiative of the British Embassy to have such fine gathering. Pleasure to see Ambassador. The floor is yours.
I'm delighted to co-host today's hybrid, or as Gintautas said, blended networking conference on the Lithuanian United Kingdom Universities Cooperation in Life Sciences. As I was just saying, I am possibly quite a rare breed in that I have a scientific background as a diplomat, so I particularly appreciate this opportunity. And my particular thanks to all of our partners, as you've mentioned, the Research Council of Lithuania, the Lithuanian RDI Liaison Office in Brussels, Cormac Consultancy, and the UK Science and Innovation Network for collaboration for making this event possible. But first, if I could just say a couple of words. We cannot move on without mentioning, of course, Russia's assault on Ukraine, this unprovoked, premeditated and barbaric attack against a sovereign democratic state, and recognizing that Putin has chosen a path of bloodshed and destruction. And this has changed the world profoundly in the last few days. We stand with Ukraine and the Ukrainian people's right to choose their own destiny. It's essential now that the international community joins together in solidarity with Ukraine. And I should like to thank all those present and online for the unity and wide support for Ukrainian researchers and students. We must not take our foot off the pedal, as the Foreign Secretary was saying when she was visiting Vilnius last week. The Prime Minister here has used the phrase, we must not let the international community hit the snooze button as the media caravan moves on over the coming weeks and months. Of course, the war in Ukraine, the COVID pandemic and climate change challenges underline the importance of international scientific cooperation in life sciences, now even more than ever. The United Kingdom stands ready to formalize our association to Horizon Europe at the earliest opportunity, which is why we clearly set out our financial commitment and announced a guarantee to fund the first wave of eligible, successful UK applicants to Horizon Europe. The British Embassy in Vilnius remains committed to facilitate scientific and academic cooperation between the UK and Lithuanian universities and research institutions, as we have successfully done in the past. My sincere thanks to the organizers of this blended conference, which has attracted more than 100 participants from Lithuania and the United Kingdom. Such high interest shows a lot of potential to expand scientific cooperation of the British and Lithuanian universities. Finally, I wish everyone a fruitful conference today as we work to reinforce our existing bilateral and international collaborative links and to identify new opportunities for research and innovation partnerships in life sciences. Thank you.
Thank you, Ambassador, indeed, for your kind words. Now we turn on to Rasa Kulvietienė, who is advisor to the Minister from the Ministry of Education, Science and Sports of the Republic of Lithuania. Rasa is joining us in online mode. I hope we also here who are meeting face-to-face will see her on the screens. Good to welcome you. Rasa, the floor goes to you.
On behalf of the Ministry of Education, Science and Sport, let me welcome you all at the international conference dedicated to the Lithuanian United Kingdom scientific cooperation in the field of life sciences. Life sciences sector is one of the priority areas in Lithuania. The revenue for this sector is among the fastest growing in Europe, and we have ambition to generate 5% of GDP from life sciences by 2030. Lithuania hosts over 15,000 scientists working in this field. Our researchers have well-recognized competencies in molecular biology, biophysics, genetics, biomedicine, enzymology, biotechnology, and others. Furthermore, we are proud that this sector can be characterized by a strong and effective science and business cooperation. Lithuania is a home for local startups, including Kazime, the company established and led by Professor Virginijus Jakštas, winner of the Kavli Prize 2018 for the CRISPR-Cas9 gene editing nano tool. To illustrate that Lithuania has an amazing pool of talent, I would like to mention that in 2020, students from Vilnius University already second time won the grand prize at IGEM, the world's largest synthetic biology competition. We see it very important to promote innovation and technology transfer centers and competence centers to test R&D-based, commercially promising ideas, create a follow-up investment or other outcomes that can be tailored to market deployment. In our days, excellent science is impossible without international dimension. The Ministry pays great attention to promoting internationalization activities and particularly appreciates the efforts of the Research Council of Lithuania to foster partnerships with advanced countries like United Kingdom. Please accept my best wishes for today's pitch session. I hope this meeting will encourage even greater cooperation between our countries. Let's solve the greatest challenges together.
Very good. Thank you, Rasa, for these encouraging words from the ministry, which is quite nearby from the Research Council of Lithuania, where we are having a small hub of this conference, and one of the co-organizers, Research Council of Lithuania, is providing us with all excellent premises for that, and I'm happy to ask Professor Romas Baronas, the chairman of Research Council of Lithuania, to greet all participants of this event.
Your Excellency, Ambassador, dear representatives, dear colleagues, ladies and gentlemen, it's a great pleasure and honor to welcome all of you to Collaborative Lithuanian United Kingdom Conference, which is dedicated to life sciences communities. United Kingdom institutions and scientists were our sixth largest partner in Horizon 2020 program. Today we are celebrating those existing collaborations and exploring the future ones. As we all know, a good partnership is the key to success in research and innovation. This afternoon, universities from both countries will present their key interests in life sciences area. And I would like to thank organizers of the conference, Research Council NCPs, LINO office in Brussels, British Embassy in Lithuania, led by His Excellency Brian Olley, and Cormac Consultancy Group. Thank you very much. I wish you all innovative ideas which could lead to closer cooperation of our countries, and I also wish you an interesting afternoon. Thank you.
Well, thank you, Professor, for welcome words. Indeed, now we turn on to our speakers with their input for our event. Before doing so, I will ask you to do your best. First of all, I'm appealing to speakers to stick to the timeline we've set up. Very ambitious task, not only for moderator, but for everybody to stay along these limited minutes for each of the speaker planned before. And of course, my another question or request for participants would be so kind to put your questions in written through the platform we are using for this conference, and we will, after this part of the event, where we'll have 3 speakers, we'll have quick and short questions and answers session and the speakers will be ready to respond to your questions raised. So with this in mind, we are coming to the first speaker on our program, Dr. Živilė Ruželė, International Program Unit at Research Council of Lithuania. And Živilė's topic is Lithuania and UK cooperation in research programs. Please.
Thank you, Gintautas, very much. Thank you for my presentation. And I would like to say, dear participant, my intervention today is aimed at briefly present about the role and activities that Research Council is doing in fostering transnational research. And I will give an overview of programs in which Council and UK funders are partners. So let's move to the next slide, and you see here that the main task of the Council are advise and deliver R&D policy in Lithuania. They help to assess the quality of research in national higher education establishment and institute, also develop and implement national and transnational funding streams, and promote international cooperation by participation in international initiatives. Main beneficiaries for the Research Council are mainly universities and research institutes, but depending on the aims and the topics of the calls, it can be also state health care providers and other state establishments such as museums, archives, or libraries. So speaking about concrete activities that foster transnational research Those activities, I must say, are implemented by a small international program unit that consists of teams of only 7 program managers. But despite that the team is not big, since 2010, Council as a funder participated in 15 international R&D programs, which logos you can see here on my slide. All of those programs are or was implemented and managed by consortiums of funding organizations, which jointly organize competitive calls for research projects, and also grants their own applicants of funded projects. Those consortiums of funders are granted by European Commission from EU 7th and 8th framework R&D programs budget, namely those programs, as you know, are FP7 and Horizon 2020. European Commission gives a support for the management and implementation of those European programs that are also inclusive to other countries worldwide, such we have in the consortiums such countries as Brazil, Argentina, Canada, and also Australia, and the participation is not limited to low and middle income countries. Such funding instruments facilitate alignment of R&I priorities, overcome fragmentation in Europe, it leading to efficient use of resources and faster scientific progress, and of course Europe's competitiveness. And in more details, as you see in the list here, programs are only co-funded and are mainly ERANET co-fund schemes, also joint programming initiatives, and other types of coordination. You see that some of them are flagged, UK flagged, and those initiatives are where among funders consortium members are UK funding agencies. In 2021, the Council participated in 15 European Union initiatives and joined new partnership aimed at funding biodiversity-related topics. UK funders are also in this partnership. In 2022, the Council is joining 5 new partnerships, such as transforming healthcare, health and care systems, Era for Health. Era for Health is a program that have a priority topics on health prevention, food and nutrition, cardiovascular diseases, and nanomedicine. Also, we will join Blue Ocean and Blue Economy partnership, partnership on driving urban transition to a sustainable future, and last but not least, Water for All partnerships. More information on all of those activities that we are doing, you can find on our website. The link provided here on the slide. And in this slide, you are seeing those initiatives that are ongoing and in which UK and Lithuania funders are involved in the implementation. I would like to take the opportunity to advertise the upcoming call of a joint programming initiative on antimicrobial resistant network call. This call aims at supporting networks and do not provide funding for research as such, but it is a good opportunity to build those networks from all over the world, because despite of the fact that only 11 countries are involved in this call, Lithuania and UK among them, but those funders will fund only coordinators of those networks, but take a membership in the networks can every researcher in every country of the world. So please check JPIMR website for more information. And my last slide would be a short presentation of last statistics on the first batch of the calls of Pillar 2 health cluster. As you see, there were 36 participations from Lithuania, and we see that we had 19 partners from UK in those consortiums. You see the list of partners in UK of Vilnius University Hospitals and other universities. We strongly believe in our international program unit that the participation in European Union co-funded initiatives facilitates the participation in collaborative projects also in Horizon Europe. And we're wishing you our universities of success in the future competitions. Thank you very much for your attention.
Well, thank you indeed, Živile. That is giving us a context for opportunities, at least some of them. And we are moving on with another speaker. And we have Tomas Andrijauskas, President of Lithuanian Biotechnology Association. While framing structuring the program of the event, we thought that industry should also be as an important part contributing to this event. And Thomas, good to have you remotely. And of course, we are keen to hear from your point of view, from the industry, how life sciences can become working more hand in hand with the businesses potentially able to grow. The floor is yours, Thomas.
Thank you. I share that our thoughts now with Ukraine, and I must say that our sector is contributing very much financially to help our colleagues in Ukraine, and we are anticipating and looking forward to hear the President Zelensky speech today to address today to UK Parliament. But we still have to do, our business as usual. And let me introduce Lithuanian life science sector and biotechnology sector. These are very much interrelated. Obviously, it's now the new star in Lithuanian economy. Very briefly about our association. So we unite over 100 Lithuanian biotech sector representatives, among others, largest Lithuanian and international biotech companies operating their sites here. 8 main science institutions, including universities and institutes. A number of Lithuanian biotech, SME, and startup companies developing their business both globally and locally, and a number of private academic researchers and scientists in the field. We focus mainly in 3 areas. So it is a life science, health technologies, and bioeconomics. And with equal approach to applied and fundamental sciences. But of course, we have to admit that the cooperation level between the academia and the business is not that we really, like. So we working very hard now to kind of bring this cooperation to a new level. Not only by combining the efforts to commercialize the science, but also providing support and knowledge, especially to researchers, how to commercialize and then how to turn the science into the economy. And we're also the member of different international platforms, associations, confederations, providing opportunities to cooperate for our members. So I think having in mind the UK's deep knowledge and very big development in life science and biotechnology. I think we should have a great potential to cooperate, and there are already good examples. But I still think we still are beyond the potential, and we should invest our time and money to find these opportunities and to kind of commercialize these opportunities. Life science and biotechnology sector in numbers, we saw a tremendous growth, and now Lithuania, the sector represents roughly 3% of Lithuania GDP, with an ambitious goal to reach 5% by 2030. If we do so, we will be among 2 countries in the world. The other one is Singapore, that already has a 5% number. So in this case, we would equal with Singapore, and that's our goal, and I think it's achievable, and we are very rapidly moving towards that direction. The sector's export intensity is 85%, and it's still growing because the sector is growing so fast, and it's obviously that we operate in a global market, so it's very natural that the country is small, so majority of what we produce here moves abroad. So export intensity already very high, and it's growing. I'm sure we'll hit 90% within a couple of years. And sector revenue in 2020 reached 2 billion euros and recorded a fantastic 87% annual growth. I must say that we don't have yet the numbers for 2021. I bet they will be again very high. I anticipate from 20 to 30% annual growth. That will bring the annual revenue in the area of 2.5 plus billion. But we don't have the numbers ready yet, because some of our large companies operating in the sector, they are listed companies on the stock exchanges that are going to disclose the financials somewhere in the middle of the year. But as I said, I anticipate that we should reach in modest valuation 2.5 billion euro sector's revenue. And over the last decade, Lithuanian biotech sector recorded a 10-fold growth, and for now it is the highest value-added sector in national economy. Private sector in 2020 employed around 2,500 employees, and our members altogether employed over 5,000 employees in the field of biotech. I'm not counting you know, the entire life science sector, including hospitals and you know, things like this, because in this case our association members would employ then over 20,000 people. And I'm really very happy that we have diverse research programs, and 7 universities provide programs, science study programs in this area. And each year these universities provide up to 500 graduates and postgraduates that enter the labor market, go to the labor market. And but the demand is so great, and we see also the wages are rising, and the demand is so great that more and more young people are favoring biotech and life science studies. And at the moment, we have roughly 1,600 students enrolled in biotechnology, in different biotechnology programs. And so this number is constantly growing, and we are very happy about that. We mapped the competences. You can see there's 5 key universities that provide this research programs and study programs. So of course, among others, we're very strong in gene editing technologies, cell engineering, metabolic engineering, synthetic biology, omic technologies, you know, and personalized medicine, and etc. So you can see that's really a diverse map of scientific competences among our research institutions. And Lithuania is one of the homes of CRISPR-Cas9 gene editing Nobel Prize technology. And here you can see in the picture Professor Jakštas. He was one of the 4 professors behind the development of this technology, although he didn't get the Nobel Prize, but he was one of the 4. Two of them got the Nobel Prize, so it's Professor Dodna and Professor Charpentier. But Mr. Jakštas, we think that his input into the development of this technology was equal as the mentioned professors. And you can see here also in the picture is a life science center of University of Vilnius. So that's where this gene editing technology was developed. So we are very happy, and obviously that since we have this know-how, and there is a number of researchers and students working around this technology, we obviously have also different companies, the startup companies that dig into this area. And because the area is really very, very wide, it's not only applied in medicinal biotechnology, but it can also be applied in agriculture, everywhere. So it's really, really a breaking through technology, and Lithuania was also behind that. And we also did a mapping of business and science cooperation areas, so you can see that we have a good examples of molecular technologies in bioeconomy, also molecular technologies in medicine and biopharmacy, digital solutions in the biotechnology sector. So digitalization is also one of the key areas what is happening now, and it's not only the trend in Lithuania; it's all over the world. The biobanks and big data and etc. So we also have a good examples of companies working in this area. And Vilnius will be hosting the largest annual Europa Bio event. It's called EFIP, European Forum for Industrial Biotechnology and Bioeconomy. So it's the largest event in Europe of this kind. So I just wanted to advertise it a little bit. It's 26th, 27th of October 2022. So, and it's going to happen. It's going to be done in Vilnius. So I really encourage you to participate and make any connections. And we have a really, really brilliant content. The topic is the next generation economies, industrial biotechnology for a sustainable society. So I think that's something which is on the agenda now in Europe. And that's it. That's very briefly, and I anticipate the questions. Thank you.
Thank you, Thomas. You are perfectly within time limits, and thank you for this insight. Definitely, we are witnessing extensive growth of the biotech and life sciences related economy in Lithuania, and the question is to not lose this pace. Definitely there are challenges to be met. Now we turn on to other presentation which is going to be done by Imran Haq, Managing Director of Ignite Life Sciences, and Shian Thomas, Executive Director International of the Skills Network. These British organizations are working within the field of life sciences, and especially their focus is acceleration of the knowledge and research, and the topic of their presentation, accelerating the translation and commercialization of life science research in Lithuania from their perspective. Imran, Shian, good to see you. Welcome. The floor is yours. Please try to stick to the time limits asking you ahead.
Thank you. We will. I'll begin and then I'll hand over to Imran. So let me see. Is this visible? Yeah. Okay, so firstly, the Skills Network is quite an unusual organisation in that we work in EdTech and then also workforce development and training. And we've been working with Imran and some other colleagues from the health sciences sector to try to identify some of the skills areas and workforce development needs that we can focus on to really help accelerate and supercharge commercialisation of the sector. So the skills network sits between major stakeholders to deliver on skills plans in priority areas. These include government stakeholders, employers, learners and employees, and training providers and education institutes. We work with private and public sector colleges, schools, universities and apprenticeship stakeholders. We provide innovative education solutions through online and blended learning content. And we work on large-scale projects and apprenticeship delivery on education and workforce development initiatives. So the main areas we focus on and we've been looking at for the sector are apprenticeships, qualifications, continual professional development programs, and also a really interesting model called boot camps, where it has been focused on looking at particular sectors with employees who already work in pretty high skilled sort of industries. So for example, people working in research and innovation in health sciences, and then looking at what kind of skills and knowledge do people working in that sector need to really supercharge innovation within that sector. And some of the areas that we've alighted upon include digital. So, for example, we are running government-backed digital boot camps, which mean that people through online and blended learning, they learn how to do data analytics, all sorts of different quite high-level digital skills, whilst they are working in different sectors. So it may be that they're working in life sciences, in business, in education, but within that sector now to ensure that it remains competitive, that the staff have the skills that are needed, they need to run these quite intensive boot camps. So we've been running those successfully, and the life sciences sector is increasingly going to need this sort of quite quick response to developing a broader range of mid to high level digital skills amongst staff there. Sustainability. So we have a huge range of solutions for sustainability for what we call non-green jobs. So that is another area for commercialisation for the sector, where again, all of the workers within it are going to need relatively high level understanding of sustainability to be able to focus research and innovation with a sustainable sort of lens. And then very, very importantly, commercialisation and enterprise. So this is something that Imran is a leading specialist in the UK for the life sciences sector. And it's something, again, that you can do really targeted interventions through online and blended learning and mentoring to make sure that people within the sector have the commercialisation and enterprise skills needed to really grow that sector. So that's just a brief introduction to some of the areas we've been working on, and I'll hand over to Imran now, who's got a much more in-depth overview of these areas.
Thanks, Sharon. Okay, perfect. Yeah, thanks. So we've over the last year or so, we've looked at different actions and initiatives that we think could help support the life science ecosystem. We'd probably look to support you in your Horizon funding program grants or in other partnership mechanisms with organisations in Lithuania. A little bit of background: I've worked at the interface between industry and academia throughout my career, and during this time I've sort of come to understand that the major barriers to translation are not the great quality of research. I mean, we heard from Thomas all the great things that you're doing there, but it's often the correct commercial mechanisms or knowledge that surround this work to allow it to flourish. I see it as a market failure of sorts. It's incredibly important to sort out. It has the potential to transform the health and wealth of your nation. It can create better medicines more rapidly, create highly paid employment, and provide a better economic return on your investment. Following this path has led me to very many things. I've got a therapeutic that's been in clinic now. I've founded a couple of startup companies. I've been involved in lots of and led lots of globally impactful collaborations. Most recently, we've set up a multi-large pharma collaboration around microbiome data, and I've worked with lots of innovators and involved in education programs over the last year. In the UK, there's a lot of lessons from our ecosystem that can be leveraged for use in Lithuania. I mean, we have the benefit of a sector with very high productivity, and we're actually quite less funded compared to many of our peer countries, but we produce more publications. We outstrip our neighbours with venture investment and biotechs created. And I guess much of this success can be attributed to the interconnectedness of the UK ecosystem and sort of the team science approach employed. And there's also lots of effort underway to build on this inherent quality, plugging gaps in the translational chain and building our hubs and expertise. And I guess the good news is that we can take many of these lessons that have been tested and used and apply them to Lithuania. I've come up with a set of proposed actions, both skills-based and initiative-based, that could be taken and brought into your program. So skills-based, we've got creation of a technical workforce, vocational courses around lab science skills, or future skills in data science, quantum computing, sustainability. So you've got abundant staff that attract in international companies or support your own internal companies. Product design thinking for your postdocs and PhDs. Can we design our research in a better way that we can have their thinking with translational thinking at the end of it? Entrepreneurship training and company founding programs. So let's have our researchers thinking about how and what they can do next, to create their innovation. We create more companies. It's a big problem. Most people don't know where to go, training, I guess, the next generation of tech transfer professionals. Can we have a course which allows business staff to, create economic and societal value out of your research? This is coupled with the several proposed initiatives. Can we do an ecosystem review or approach, see what things can be brought? I saw Thomas has done a great job with this, but can we find areas where we can build on this, on things and align things on innovation pipelines and bring in international partners? Can we also look at immediately translational work and support this into development? Creation of different kinds of accelerators, for example, a pharmaceutical accelerator, target product profile, what's it going to look like in a patient, what do you need to do for next steps, and that supports funding of these kinds of companies and in licensing. And obviously, very importantly, can we create a fund structure that attracts inward investment into Lithuania? So, use cornerstone funds to create a larger fund. The last thing you want to do is have small amounts of funding that result in your companies having to be offshored or the IP going out of Lithuania, because there's just not enough funds to continue moving things forward. It's a very brief, quick overview of these due to time, but got several very experienced partners and consultants and people who are very senior in the medicines discovery capital, others working in sustainability, and others from the University of Birmingham in tech transfer, partner organisations like Skills Network that you saw with Sean and Accenture, and how you can work with me. We're very happy to help support the grant development, but where we're really interested in being involved is the incorporation of maybe work packages of these variations into your grants. You can contact me on the email, and I've got a detailed proposal document, overview document of this, which I'm happy to share as well. Thank you.
Well, thank you, Imran. Thanks, Shian, for joining us, for contributing to this event. I think this challenge to create real bridges between research and industry is in the minds of many in Lithuania, and I guess having working models and fine examples of experience from UK might encourage this experience to be implemented and successfully used for our economic growth within life sciences. Having said that, we are now at the end of the 3 presentations where we have planned quick questions and answers. We have one question, and I think it's going to be to Živilė. Are there any plans for calls by Research Council of Lithuania for joint research projects between UK and Lithuania universities in life sciences? If you could respond in one or another way, that would be nice, but very natural question, I guess. Yes, please join us in front of the cameras.
Yeah, we do not have actually bilateral program for Lithuanian UK collaborations as we have with some other countries, for example, Ukraine, Japan, even Japan, and other neighboring countries, Latvia and Taiwan program. But as I said, we can collaborate in those transnational programs. So as I said and showed in my slide that we have some common programs, and those programs that are ongoing and future Horizon Europe partnerships will have an annual calls for proposals. So you have to search for information to reach us, to find out more, and to be aware what is happening in Horizon Europe in terms of partnerships. But you can always approach us, International Program Unit, and NCPs in Research Council to have more information.
Thank you, Živilė. I think with this, we are now turning on to another part of our event, exciting part, I would say, pitching session involving universities on both sides, Lithuanian and UK. The goal of this session is to highlight research potential and priorities within respective universities, also see ongoing scientific collaborations and maybe some ideas for the new ones. Therefore, I would just ask all speakers to be ready to fit into a 7-minute challenge. Please understand our request. And indeed, it is my great pleasure to announce that already mentioned speaker will be with us today. Tomas Andrijauskas was mentioning the star of Lithuanian life sciences within the field of gene editing, is going to speak on behalf of Vilnius University, Professor Virginijus Jakštas, who is chairman of the Council of Vilnius University Life Sciences Center. Professor, I hope you are with us, and the floor goes to you.
Hello. Thank you. So my name is Virginijus Jakštas, and I'm a chairman of the Council of Life Science Center of Vilnius University, and it's my pleasure to be with you today and start this pitching session. So Vilnius University was established in 1579 by the Jesuit order, and it's one of the oldest universities in the region. And the bell tower that you see in the background belongs to University Church. which is part of UNESCO World Heritage Site. And you can see a lot of churches in Vilnius, but it doesn't necessarily mean that we go to pray to the church every morning. In Vilnius history and modern times, peacefully live together. And I think that the brand new building of Life Science Center that was opened in 2016 is a nice illustration of that. The Life Science Center community is comprised of nearly 1,600 people, and staff comprises around 500, including 300 researchers with PhD degrees. The rest 1,200 are students that are enrolled in bachelor, master, and doctoral studies programs. And these numbers make a very favorite student and teaching staff ratio at the Life Science Center of Vilnius University. The Life Science Center functions as a research university, since the major part of the annual funding that reached nearly 12 million euros last year comes from research grants, and a much smaller part comes from the study subsidy. And the funding increases gradually over the years, indicating that researchers at Life Science Center are quite competitive in obtaining funding. And we are running bachelor, master, and PhD programs at Life Science Center. And the bachelor program includes different topics, including biology, genetics, microbiology, molecular biology, and others. And the number of bachelor studies at the Life Science Center of Vilnius University is growing despite of the unfavorable demographic situation in the country. The master studies includes also very different topics, including biochemistry, biophysics, genetics, microbiology, molecular biology, and among the others. And we have currently 130 doctoral students at Life Science Center, and the PhD program is at Life Science Center is steadily growing, and we aim to have more master and PhD students in the future. The largest number of students are enrolled into biochemistry program, however, significant numbers are enrolled in biology and chemical engineering programs. And the students at Life Science Center are really great, and we have really talented students. Indeed, Life Science Center students team won 2 grand prizes in the international iGEM competition, leaving behind hundreds of teams from different universities over the world. And very recently, a PhD student, Joana Smirnovienė, became a laureate of the L'Oreal competition for women in science. And the academic staff of Life Science Center is doing equally well. In 2020, they published nearly 200 papers, and large of them fall into the D1, Q1, and Q2 categories, and included also papers published in flagship journals like Molecular Cell, Nature Group, or Cell Metabolism. And in 2020, Life Science Center achieved another milestone. A partnership institute on genome editing has been established as a joint venture between Life Science Center of Vilnius University and EMBL, European Molecular Biology Lab, that is a flagship of molecular biology in Europe. And some of you are probably aware that bioinformatics branch of EMBL is located in Hixton, UK. And the Ministry of Education, Science and Sports allocated 6 million euros for establishment of such center. And this center established at Life Science Center became a 7th partnership institute of EMBL. Most of them are located in Scandinavia, However, one of them is located even in Australia. So why genome editing and why Life Science Center? So researchers at Life Science Center were among the pioneers of genome editing technologies, and they continue to deliver new genome editing tools and technologies. A newly established institute was able to attract 6 young group leaders from different parts of the world, including UK, Norway, Switzerland, and US. And these new group leaders will be focusing on different aspects of genome editing technologies. And currently, principal investigators are now establishing their own research groups, and I should say that these groups became focal points for the students. So I'm probably running out of my time, and I should stop here, and thank you for your attention.
Well, thank you indeed, Professor. The beginning with the churches was excellent to revive our attention and context of how university mission is changing and in what it can come in terms of results. From Vilnius University, we have next to Professor Šiksnys, another speaker, co-speaker, Indrė Klimantavičienė, who is at Vilnius University Hospital Santaros Klinikos and is in a capacity of head of innovation and technology transfer division. So Indrė, we can see you, and I'm sure in a second we can hear you. The floor is yours.
So thank you very much. My name is Indrė Klimantavičienė. I'm the head of innovation and technology transfer division here at Vilnius University Hospital Santaros Klinikos. And it's a pleasure for me to present you our hospital as a potential partner for future cooperations. Vilnius University Hospital is one of the major hospitals in Lithuania, and it was founded by Vilnius University and the Lithuanian Ministry of Health. Its first department was opened in the early 1980s, and today we are among the leading tertiary level healthcare and research institutions in the Baltic states. Providing a training base for Vilnius University and being in a close cooperation, our hospital is involved in practical and scientific medicine, education for students and resident doctors, cover professional training for medical specialists, conducting research and creating innovations. One of the main goals for us is to create, develop, and nurture a basis for healthcare, teaching, and research in Lithuania. The hospital has around 6,000 of employees with more than 1,600 being physicians and around 2,000 of nurses, providing a state-of-art healthcare services for the patients, not only from Lithuania, but also foreign countries. There are around 2,000 inpatient beds, where approximately 82,000 inpatients are treated, and more than 40,000 complex surgeries are undertaken annually, including all types of organ transplantations. Complex ambulatory health care is also well developed at our hospital, with more than 1 million outpatient consultations provided yearly. A hospital is also a leader in health information and communication technologies and medical informatics. The institution, as already mentioned, contains an extensive basis for specialist training and serves as a major healthcare center for residency training in various medical fields. There are working more than 370 employees holding a doctoral or professor degree, ensuring the highest background for research and innovations. We have 35 specialized medical centers and are a full member of 12 European reference networks. Our priorities in scientific and clinical activities are heart and vascular medicine, transplantology, medical genetics, and specialized pathology, oncology, including oncohematology, molecular and personalized medicine, surgical oncology, radiology and nuclear medicine, children's diseases and rehabilitation, including maternal and child health, also fertility treatment. The hospital has expertise in research and development, phase 1 to 4 clinical trials of investigational medical products and medical devices, observational studies, and international registries. Biomedical research activities are focused on clinical trials, both drug and medical devices, studies on chronic, non-infectious, and infectious diseases. BULS has a modern infrastructure that allows patients to participate in our clinical trials and other biomedical research. Last year, for example, we had 443 biomedical trials carried at Vilnius University Hospital. The following biomedical research activities were carried out in the epidemiological, retrospective, prospective studies, drug and medical devices clinical trials, research experimental development projects in cooperation with other research institutions as well. Research done by PhDs as well as undergraduate students. And the number of clinical trials are constantly increasing, and at least 90 or to 100 studies are conducted at a time at a BULS. We also have a biobank infrastructure with more than 50,000 different samples collected with a wide profile of covered diseases, including hematological, oncological, infectious, genetic, rare, and chronic diseases, which could be used in cooperation projects. BULS participate in a number of R&D and I projects. We have participate in 14 multinational consortiums implementing projects under various international programs, such as Horizon 2020, COSME, COST, and other international programs. In areas of COVID, cancer survivorship, rare disease, infection prevention and care, cardiovascular and blood, effective and integrating healthcare. And I marked here the projects who have the partners from UK, and for example, Sirocco Exchange or EcoQuip Plus projects dedicated to, let's say, innovative public procurement are coordinated by UK institutions. Among the partners from UK could be mentioned University of Stanford, University of Nottingham, the Open University, Department of Health, Medicine and Healthcare Product Regulatory Agency, NHS, Health and Social Care Informatics Service, University of Edinburgh, and more others. And last but not least, here are the national projects our researchers and employees are participating. They are funded by national programs, and I just wanted to mention the areas of interest are immunology and genetics, oncology, psychotherapy, acute pancreas, cardiac surgeries, abdominal surgery, COVID, laboratory diagnostics, prognosis, yes, human biological resources, innovative medical technologies. We are also very much interested in artificial intelligence solutions, so how they could be used in radiology, for example, and so on. So thank you very much for this opportunity to present us, and for more information, please contact me.
Yes, thank you, Indrė. There are questions coming up at this point of the pitching session, but please understand, colleagues, that we need to stick to our schedule. We will be able to connect you all in one way or another after this to follow up the initial thoughts. Indre, there will be a question for you coming about how this biobank functions. Can you work with industry partners? But we need to move on. Please do not be surprised that some of the participants will be coming up to you, or Imran Haq, who was speaking before you. Therefore, we will be doing our best to link everybody with each other. So now it is time for the first UK university to step in, and we have University of Lincoln and two colleagues, Steve Bevan and David Cobham, will be speaking. I hope everything is fine with connections. Gentlemen, the board, the floor or the screen is yours.
Artur Gintautas, can you hear me okay? Thank you. Sveiki Atika I visus mūsu draugus Lietuvoje. Thank you very much for this opportunity to speak to you today. My name is David Cobham. I'm the Dean for Transnational Education at the University of Lincoln in the UK, and my colleague Professor Steve Bevan will pick up on the technical issues immediately after I've completed. So just to introduce you very quickly to Lincoln. Lincoln is a wonderful small city in a very picturesque part of the East Midlands of the UK, with a fantastic cathedral, wonderful castle, and actually a medieval town centre that reminds me very much of the centre of Vilnius when I've had the pleasure to visit. The university, however, is very young and very modern. So the university campus in Lincoln has really only been functioning for about 30 years. But in that short space of time, we've built a fantastic university, which is responding partly civic aspects and our local economy, but internationally as well. And over the short period of time that the University of Lincoln has been operating, it has developed and grown in quite a staggering way. So we've already in that short time have a QS 5 stars rating. We have TEF Gold for our teaching. And also last year we were given the award of the Young Modern University of the Year for the UK. So a university that we're all very proud of. Just before I hand over to Steve, just to mention some of the activities we're involved in terms of transnational education, so where our programs are delivered in countries overseas. And we have a number of very good quality partners around the world that we work with. But perhaps I could just spend a minute or so talking about the partnership we have with the University of Latvia. This was established under a similar initiative 2 or 3 years ago, with the Latvian government interested in establishing links between universities in Latvia and the UK, with strong ties into the computing information technology industry sector. And we've set up a teaching partnership with the University of Latvia, which allows the students to achieve a dual award. So students can graduate with their local degree from the University of Latvia, but also through the dual award mapping that we've established, they can also graduate with the University of Lincoln UK award. The programs can be studied entirely in Riga, but if students want to, they can come and do a semester or a year in Lincoln. And the whole partnership is peppered with opportunities for collaborative study, guest lectures, visits to each other's institutions, and we're very proud of the partnership. And if any of the colleagues from the UK or from Lithuania would like to speak to me about the model, very happy to talk about how that operates. We've recently had a QAA, Quality Assurance Agency, review of this model of delivery and got a very complimentary report. So we're very comfortable with the model, that it's robust.
Thank you very much. So I'm going to speak about the research that we do at Lincoln, firstly as a broad university and then more specifically in terms of life sciences. So as a university, we strive to engage in research that has both a local impact and global reach, addressing the vital role that education, scholarship and research plays in ensuring that in our rapidly changing world, no one's left behind. So we've framed our research around these key development goals as a modern university has given us the flexibility to do that. These United Nations Sustainable Development Goals are an urgent call for action to tackle some of the world's most pressing problems, and they recognise that Ending poverty and other deprivations must go hand in hand with strategies to improve health and education, reduce inequality and spur economic growth, all while tackling climate change and working to preserve our biosphere and the species on the inhabited Earth. So each of our research themes, research institutes, centres and groups are aligned with their respective UN Sustainable Development Goals as a constant reminder, both internally and externally, that research should have impact and real-world relevance. So we've designed 6 main themes to our research activity. These span the entire university's research ambitions. They are rurality, health and well-being, sustainability, digitalisation, communities and heritage, and of relevance to the life sciences with a strong focus on rural health, agri-food technology, planetary health and food manufacturing, with each of these being a major focus of ongoing and growing research activity. So the recent opening of our medical school allows for an increased expansion of health and well-being, and we envisage that will be a centre of excellence and a focus of development over the next 2 to 5 years for us. And that means that we're able to move into these areas and combine with partners to establish collaborative links. So within the School of Life and Environmental Sciences, more specifically, research is predominantly focused on the themes of health and well-being and sustainability, although there is overlap with co-aligned groups in other areas as well. So of particular note within health and well-being is our expertise in diabetes, metabolism and inflammation, as well as microbiology and biotechnology, while within the theme of sustainability, we have significant research interest in climate change, particularly looking at the Greenland ice sheet and the loss of the polar ice caps, soils research, and ecology and evolution in its broadest sense. So we're open to research collaborations across any of our research areas and currently have over 80 PhD and MSc students within the school, as well as over 1,000 undergraduate students studying for a first degree in subjects as diverse as biomedical science, biochemistry, ecology and conservation, zoology, biology, animal behaviour and welfare, and bioveterinary science. At the master's level, we offer MScs in microbiology, biotechnology and clinical animal behaviour, and we're able to support international students and study abroad options in all of these areas, as David indicated. So I'll stop there. Thank you very much for listening, and if anyone would like to get in touch, then we're more than happy to address questions.
Well, thank you, Steve, and thanks, David, for your presentation. And now we turn on to Lithuanian University of Health Sciences, which is based in Kaunas, and we have Laurynas Irukas with us, who is head of development department. Good day, Laurynas. The floor is yours.
Hello. I hope that you see my presentation and hear me well. I want to thank you, first of all, for invitation in this event, which probably will help us to expand the scientific collaboration. And let me introduce to Lithuanian University of Health Sciences. So this year, university celebrates 100 years of history.
Can you hold on a second?
The University of Lithuania was established in 1922. And as a health sciences university, we have ambition to be a leading university of health sciences. The research with education, with clinical practice, we are trying to make an impact for the society, to make everyone healthier, to help live longer, and also to live better. And in the university, we have around 8,000 students. We have more than 1,200 academic staff. 23% of our all student body is international students from 87 countries. And according to the national evaluation, we are #1 in the biomedical research in Lithuania. And now this year, it's the perfect time and opportunity to come in Kaunas, in the city Kaunas, which is European Capital of Culture 2022. University consists 2 academies, Medical Academy and Veterinary Academy, which means a broad understanding about the life sciences. We have 7 faculties: medicine, dentistry, pharmacy, nursing, and public health in the Medical Academy, and also veterinary and animal science faculties in the Veterinary Academy. University is also a stakeholder of two university hospitals, Kauno Klinikos and Kauno Ligoninė, also the stakeholder of gymnasium and two husbandry centers. Collaboration with the list of partners and organizations is the key of successful studies, research and clinical work, and we are happy to be members and having relations with EAT Health Network, with WHO, CERN, and other well-known organizations. Our research priorities is related with university structure, and One Health is a perfect definition describing it. We have leading scientific groups in biopharmacy, neuroscience, oncology, cardiovascular research, digestive research. And we can collaborate from the basic research via clinical studies until the population research. There's examples of the latest works in priority groups. There is number of COVID-related studies, cardiovascular, artificial intelligence tools development, cell therapy, Parkinson's disease treatment study with a gamma knife, biomarker studies in gastrointestinal research, and there is numbers of publication and scientific papers in well-known public journals. And in another side of the mirror, we have priorities and strong scientific groups in animal health and welfare, husbandry technologies, and safer enriched food. There is a list of research priorities that makes our research multisectoral, transdisciplinary, and collaborative. We are happy of collaborations and partnerships with United Kingdom universities, University of London, Imperial College London, University College London, Oxford, King's College, Cambridge are the top institutions that we are publishing collaborative research, and you see numbers of it. And we have a list of the history and last granted UK partnerships in Horizon 2020, COAST, and other sponsored research initiatives with the GSK and the Cerner companies. The main message from me today is that we are open for new partnerships and collaborations. There's a list of coming calls that we have strong interest to participate as a partner. So do not hesitate and contact me if you see any possible collaboration initiatives in Horizon Europe, MSK networks, or all other possible calls that are coming in the life sciences. So thank you for your time. My contact is here, so do not hesitate and contact me.
Excellent, Laurynas. Thanks a lot for your concise and very informative presentation. And now then we could hear a presentation pitch from Yulia Kravchenko, Technology Transfer Project Manager from Kaunas University of Technology.
Yes, hello, can you hear me?
Yes, we do.
Okay, perfect. And I guess you can see my slides too.
And they are on.
Perfect. So, hello everyone, I'm Yulia, as I was presented. Today I'm representing Kaunas University of Technology and National Innovation and Entrepreneurship Center. Some information about our university. So we have 9 faculties, 8 institutes, 2 integrated centers of research, studies, and business, 4 campuses in 3 cities, mainly Vilnius, Kaunas, and Panevėžys. Also, Kaunas University of Technology is one of the largest technological universities in the Baltics, with more than 1,000 academic staff and more than 8,000 students. What we are very proud of is our spin-offs and technologies which we license. So in the year 2020, we had 33 technologies licensed for the companies and more than 30 spin-offs. When we talk about the life sciences, mainly 3 institutes are working in this field. It's a Biomedical Engineering Institute, also Professor Baršauskas Ultrasound Research Institute, and a Health Telematics Research Institute. I will go through every of them quickly.
So let's start with Biomedical Engineering Institute. It specializes in applying rapidly progressing electronics, sensoric, computer science, and knowledge engineering technologies for the diagnostic and treatments of various medical problems. The main research areas right now are methods for biosignal processing, physiological and biomechanical information sources and sensor investigation, also research on medical imaging processing techniques and algorithms. We are very proud of one of the current, let's say, patented technology, a wrist-worn device for patients with post-stroke conditions. It was developed with the collaboration with Vilnius University and currently is being licensed to Telematics. I'm presenting it to you because, well, it's one of the biggest research areas in the Biomedical Engineering Institute. We are very looking for the partners in the field of arterial arrhythmia and, just this field. Another institute is Health Telematics Science Institute, and it gained international recognition after creating the world's first non-invasive absolute value intracranial pressure measurement technology. And currently, it's working on a non-invasive systems for glaucoma diagnostics, for brain function impairment prevention systems during open heart surgery and gynecological surgery, and other other areas. I guess you will get the slides, so you will be able to look more into detail with that. So again, we are very proud of this device. It's a non-invasive intracranial pressure. It's already gained a CE marking and currently is under the clinical trials. So we're also looking for some collaboration in this field. And the last but not least is the Professor Baršauskas Ultrasound Research Institute. It's working for more than 60 years and has a broad knowledge and know-how on development of new advanced ultrasonic measurement, imaging, non-destructive testing techniques. When we talk about the biomedical and life science field, they work on the application of innovative data fusion-based non-invasive approaches for management of diabetes, also for some researchers and technologies in the field of diagnosis of intraocular tumors, also for the diagnosis of skin cancer and endoscope capsules. Again, we are looking for partners in all the fields that I just mentioned, but one of the most interesting for us is the field of the skin tumors. So we have a patent in the complex analysis system for automatic early stage diagnostic for malignant skin tumors. And well, its biggest, let's say, advantage for the systems which are already developed is that it not only evaluates the skin surface tissues and how it changes, but also evaluates the tumor penetration into those tissues. So if you're interested in the collaboration in this field, we are very open for that too. And very shortly about the current collaboration with United Kingdom universities. So we have a lot of joint research projects with universities in the Cambridge, Oxford, Glasgow, Edinburgh, and other cities. Currently, we enrolled in 9 Horizon projects with the universities in different cities in the United Kingdom. We also have a lot of collaborative scientific articles and book chapters published. For example, just in Health Telematics Institute, we have more than 60 scientific articles published. And we also invite researchers from different United Kingdom universities to give lectures for our bachelor and master students in the programs of life science, for example, biomedical engineering. And some of our researchers, for example, the head of Health Telematics Institute, Professor Arminas Ragauskas, he's also giving lectures in some of the universities in United Kingdom. So that would be shortly it. I hope that we will find points for the further collaboration, and you can see the contacts on the screen. Thank you.
Well, thank you, Julia, for your contribution. Concise, informative, and I hope each of the presentations can bring some follow-ups being arranged. We can jump onto Klaipėda University presentation, and we have with us Aelita Skarbalienė, Associate Professor Vice Dean of Academic Affairs from our university on the seacoast in Lithuania, but here with us in Vilnius. So Aelita, please.
Thank you very much, Gintautas. It's a great pleasure to be here in Vilnius to meet some participants in person, to see everyone else on the screen. Klaipėda University is actually the youngest university in Lithuania, but very modern and fast moving forward. It was founded in 1991 to meet the needs of Lithuanians' development, to solve, first of all, problems of region development, of the culture, education, research, industry, technology, economy, etc. And additionally, it was the need to decentralize higher education and to foster the idea of Lithuania as a maritime state. And today we see Klaipėda University as a higher education and research institution that meets all above needs and creates advanced knowledge and technology. It is important to mention that according to the statistics, Klaipėda University is the second Lithuanian university in terms of internationalization. And even though we're small, but we're really into international cooperation. So we're young, however, agile institution. And for example, in the budget structure of Klaipėda University can be seen that more than 60% of all income we receive from project and research grants, and that proves our competence in acquiring funding from different institutions. Klaipėda University, as I mentioned, is still growing university. We're still developing a new infrastructure, new research networks, and new possibilities. You could see in previous slides a campus of nice Gothical buildings, and we have some new modern ones as well. Klaipėda Science and Technology Park is the center for the promotion of the innovative environment of Klaipėda region, striving for close and purposeful cooperation between science and business for creating conditions for startups ecosystem. Then you can see one of auditorium complex. Our business incubator has been opened and business enterprises engaged in production experimental activities are being established there. A new complex of Marine Research Institute has laboratories of coastal environment and biochemistry, waterborne transport and air pollution, mechanical and marine engineering, fishery and aquaculture, etc. We have all three levels of studies. Pretty nice number of students, 60 laboratories at all, and even the fleet of 3 vessels. And we are the only one university in Lithuania that has a fleet, and some of the ships are used for research, for marine research. Klaipėda University is a 112th place among Eastern European universities, and we're among the top 200 universities in the field of oceanography worldwide. Since 2019, Klaipėda University is a member of the EU Connexus European University for Smart Urban Coastal Sustainability. And after some reorganization, now we have 3 faculties, and 2 of them are directly related to what we are talking today, life sciences. Thank you very much. You can see our fleet, our nice vessels and actually international teams are working on those. And if mention previous and ongoing cooperation with the UK universities, we have a different kind of that cooperation agreements for the variety of activities with some universities. We were working and now still working on different projects, especially in health sciences, and we have even some consultations on developing the new study programs and postgraduate study programs from universities in UK. And if we look to the strategic priorities in life sciences, we have the objective to provide smart health solutions to promote health and well-being for all age groups. One of the most important priorities is to establish and develop the university hospital and promote clinical research. We're happy that we're in the process of establishing the university hospital. As I mentioned before, we are part of EU Connexus European Universities, and Life Sciences and Biotechnology Institute was established not long ago to promote and coordinate applied research activities in life, health, and agricultural sciences, including marine sciences, medicine, molecular biology, biomedical and clinical research, nutrition sciences, pharmacy, chemistry, etc. And we're working on developing the STEAM Center for nature, technology, engineering, and creativity education. So I really try to be short because we're quite late, but thank you very much for your attention. And if you have any questions now or later, I'll be glad to answer those. Thank you very much.
I suggest that now we would ask Lithuanian Sports University to give their presentation, and we have Tomas Venskūnas, Associate Professor.
I'm Tomas Venskūnas, representing not a very large university, very specific university, and we have here Institute of Sports Science and Innovations to represent or conduct research at the university. Our staff is about 26 full-time position researchers, and we have about the same number of PhD students, and working in major 6 areas in groups, mostly concentrating on skeletal muscle structure, fatigue, adaptations, and rehabilitation. Also conducting research on adaptation to different temperature conditions, and also investigating cognitive function, motor control, biomechanics, some studies on neural rehabilitation, and looking at the mechanisms and genetic factors of the adaptation. We have coaching science research and adapted physical activity and health and physical activity. So a lot of research which is concentrated on the well-being in humans and the mechanisms of adaptation to different types of interventions or conditions, such as acute and long-term adaptation studies to heat, cold, training, altitude, different nutrition patterns. And we are looking at the metabolism, blood composition as a risk factor for developing disease. Now we are interested also in microbiota, and of course we measure muscle function and different characteristics of skeletal muscle properties. So we also investigate cognition and conduct different types of experiments and measurements, including muscle electrical activity and the brain electrical activity. We use ultrasound machines and different type of modern equipment, which we have upgraded recently to quite large extent. Also, what we do is we run quite small animal facilities where we have mouse model, and we look more to the mechanisms there, why the adaptation is going one way or another. And the adaptation, first of all, is to physical training and also to dietary interventions. So we are interested in metabolism again, skeletal muscle function. We do measurements in vivo and also ex vivo. So we look at the activity patterns.
It seems that internet connection perhaps is not good. Well, in this case, I think we have heard part of this presentation. Let's try to hope that it's larger part we've heard. And I suggest we now would move to Northumbria University. If we have Dr. Meng Zhang, an associate professor in the Department of Applied Sciences. Yes, we can see you. Yeah, the floor is yours, please. Good to have you with us.
Can you see my screen?
Yes, we do. Please proceed.
Right. Okay. Good afternoon. Thanks for this opportunity to present some research we're doing in Northumbria University here. My name is Meng Zhang, and I'm associate professor in the Department of Applied Sciences. Initially, I would like to introduce Northumbria University. Northumbria University is located in a city called Newcastle upon Tyne, which is located in the northeast of England. And we are very proud to present our landmark is Tyne Bridge, which is sit over the River Tyne. And I believe the Newcastle United football team is well known to the world as well. But is less well known for the people outside the UK is there are two universities in the Newcastle upon Tyne, and these two universities are very close to each other, but 5-10 minutes walking distance. So there's a lot of collaborations between these two universities. Northumbria University is the younger university and only gained its university status in 1992. But we have a very active and ambitious research agenda. The Department of Applied Sciences has 85 academic staff to date, and we cover a wide range of subjects from microbial biotechnology to biomedical sciences and to chemistry and nutrition sciences. Due to the applied nature of our research, we have a really good relationship and lots of collaboration with industrial partners, range from international companies such as P&G and to the regional small or medium enterprises. Today, I'm only going to introduce some research. I'm involved in this research center called the Hub for Biotechnology in the Built Environment, HBBE. HBBE is a UKRI-funded research center. It is the collaboration between Northumbria University and Newcastle University. So in HBBE, we have a vision to create a new generation of buildings which are self-sustaining and sustained by life. What do we mean by that? So we think in the future, all the buildings will be living buildings which are responsive to their nature environment and also can utilize the engineered living materials to reduce the inefficiency in the traditional construction process. Also, we see in the future the buildings can metabolize their own waste, reduce pollution and generate valuable products. Also in the future, we imagine the buildings can modularize its own microbiome for the human health benefit. To achieve this vision, we created 3 research themes. Building metabolism theme led by my colleague, Professor Gary Black. This theme aimed to utilize microbial cells to treat the waste from the built environment to generate either high-value chemicals or the energy which can feed back into the building. So this group not only focus on to use synthetic biology, create those novel biological cells or system to go through this process. Also, the group start to look into how we build our infrastructure. So in the future, the building we created can process its waste in situ, rather than rely on the current system, which is a centralized industrial scale infrastructure for waste management or treatment. So the second theme is living construction theme, led by myself and Professor Martin Dade Robertson, who is an architect but has synthetic biology background. And this group, we aim to create next generation bulk engineered living materials, and which can intelligently synthesized or activated through microbial process. We study a wide range of biomaterials, including biominerals induced by bacterial cells, microbial cellulose, and mycelium composites or mycelium laser. We're also interested in bacterial spores-based shape-changing materials. In our group, we try to develop computational model cross biology and engineering, and create digital tools and customize the bioreactors for fabrication of biomaterials and complex structure. So our approach is to combine hardware, software, and wetware. In this case, will be microbial cells to create an innovative manufacture platform. The third research theme is microbial environment, which is led by my colleague, Professor Darren Smith. This theme or this group aim to better understand and computationally predict the interaction between the built environment and the microbiome, and enable us to enhance or cultivate the healthy microbiome. So in the last few years, there is an increased awareness in the importance of the environmental microbiome to the human health. But there's very little research on how we design the healthy microbiome environment. So this group aimed to create technology enabled building can sense microbiome in itself, and also it will inform evidence-based design of the space in the building, taking into consideration of microbiome and human interaction within the building. So we create a wide range of facilities to enable us to develop those technologies from nanoscale, microscale, macro scale to the human scale. And also on top of collaborate with many academic institutes, we also established very good collaboration with all kinds of stakeholders. So we were very open for the collaborations. Very last, I would like to thank you for listening to my presentation.
Yes, thank you, Meng, indeed for your contributions, for joining us. It worked very well. And now I think we just in a little bit catch-up mode will get in touch with St. Andrews University, and I hope Brad McKay is with us and everything is going to be fine with slides.
Okay, can I be?
Yep.
Could I be here?
We have all in place. Please proceed.
Super. Well, first of all, it's a delight to be here today with you. Obviously, we're living in the brave new world of digital connectivity, but actually there are some challenges with it. My name is Brad Mackay. I'm the Vice Principal International Strategy and External Relations for the University of St. Andrews, and on occasion a Professor of Strategy in the Management School. Just to give a little bit of an overview of St. Andrews. So we're founded in 1413, so we're Scotland's oldest university and the third oldest university in the English-speaking world. We have just over 10,000 students, of which about just over 20% would be postgraduate and just under 80% would be undergraduate, and around 2,800 staff, of which just over 1,200 would be academic, and then about just over 1,500 that are administrative. Just a little bit less than half our students come from outside the United Kingdom, and we have over 140 countries represented in our international community. And our university has 4 faculties, which are the Arts and Humanities, Divinity, Medicine, and the Sciences. But the operational units for the university are very much around our 20 schools. We're a relatively small institution, and as the slide states, we're renowned for the quality and impact of both our research and teaching. And the fact that we are relatively small means that we can bring sciences together in interdisciplinary and novel ways, which helps us to really push the boundaries of science. And of course, I'll be focusing on life sciences in this presentation. We have about £45 million by 2019-2020 in research funding, significant strengths in both life sciences and translational research, and lots of work going on impact as well through spinouts and other things. And I'll just come back to that in a few minutes in my presentation. So in the life sciences, just to give you really some of the highlights in terms of some of our strengths, and again, very much a theme of what I'm talking about is our ability to bring together different schools to focus on challenges and research questions in an interdisciplinary way. So for example, we have the Biomedical Sciences Center, which is interdisciplinary, and it brings together or it interfaces with biology and medicine, chemistry and physics. And within our biomedical sciences research complex, we have research at the chemistry biology interface, which uses chemical tools to explore biological processes, and research in this area probes scientific questions around at the molecular level primarily. So research programs might include things like the elucidation of protein structures and functions, the discovery of novel anti-infectives and biosynthetic pathways. And research really ranges from infection and immunity to biophysics, to molecular medicine, and to chemical biology, and draws very much on an integrative approach to science. Our Center for Biophotonics at the University of St. Andrews was established in December 2019 with the mission of promoting interdisciplinary research and training at the interface between advanced optical imaging, photonics, and the biomedical sciences. And in areas like our neural control of movement lab, we have research conducted in this laboratory which aims to provide a better understanding of the neural control of movement with a focus on motor systems and the brainstem, spinal cord, and so on. Health informatics, we have strengths, particularly in work that's been internationally recognized in oncology, and we've just relaunched a institute called the Sir James Mackenzie Institute for the Early Diagnosis of Human Disease, and this institute has 3 research platforms, which includes biophotonics and early diagnosis, digital diagnostics and emerging technologies, and then health data research as well. And then also we have the Organic Semiconductor Center, which is again interdisciplinary, and the Interdisciplinary Research Center, which brings together physicists and chemists to undertake collaborative research on remarkable plastic-like materials that can emit light. And very much this work that's been happening within our labs and the life science part of our university is also having quite considerable impact. So just to give you a flavor, for example, of some of the spinouts that have emerged from these interdisciplinary research programs, We have spinouts like Bespoke Photonics, which are pioneers in computational imaging and microscopy, and they can view large-scale 3D imaging in opaque tissues, which improves outcomes in cancer research and neuroscience. Xgenics, they focus on CX bonds, which are essential in pharmaceutical discovery and manufacture, and they've got patented and proven platform technology which enables the discovery of new enzymes and the development and delivery of bespoke and sustainable bond formation, CX bond formation. Actiframe, which provides medical device manufacturers the ability to incorporate antithrombotic functionality into their range of vascular diagnostic and procedural products. Pneumogen, which is another spin-out, is developing a glycan-targeted intranasal therapy for the pan-viral treatment of infectious disease of the respiratory tract, or as my colleague that founded it says, basically a therapy for treating COVID. And St. Andrews Medical Devices is a social enterprise under brands such as ArcLight, which produces low-cost medical devices for optometry and hearing. So that just gives a little bit of an idea of the interdisciplinary approach we take in the life sciences and some of the impact that it's having through producing social enterprises and spin-outs here at the university. We don't have extensive connections, although we do have peer-to-peer collaborations with institutions in Lithuania. For example, we've got some connections with Photonics and Vilnius, but very much delighted to be here today. And with that, I'll just bring my presentation to a conclusion. Thank you.
Thank you indeed, Brad, for making this and staying with us. All it worked excellent. St. Andrews is now leading among leading institutions, if not to say leading in UK, and then that's really great to have you with us. And we will see what can be followed up after this. But in any case, we would like now to keep up with the UK institutions to do their presentations, and in a planned sequence, I would like now to proceed forward with University of Glasgow, and of course I do hope that we will have Tom Evans with us. Yes, I see Matthew Walters with us. Pleasure is ours, and I hope everything will work well with presentation. Please proceed.
Fantastic. Thank you very much indeed. Good afternoon, everyone. I'm going to begin with a number of apologies. We've had not only the technical issues that have caused some trouble, there have also been some human factors as well. Professor Tom Evans, my colleague, has been unfortunately unable to join us at very short notice, and as a consequence, I'm stepping in. I'm on call at the moment in the hospital, and I've put these slides together in the space of about 10 minutes. So I hope that you'll be able to see my slides. Starting off with a picture of Glasgow as it looks this morning. So Glasgow, as you know, is a large urban city in the west coast of Scotland. We're a relatively new and young university compared to the University of St Andrews, in that we're only 550 years old. So we're relatively fresh, enthusiastic, and looking to do business with the rest of the world in the various domains where we profess some expertise. There are 4 colleges within the University of Glasgow, and this is one of them, the College of Medical, Veterinary and Life Sciences, and the one obviously that's of most relevance to the conversations we're going to be having today. This is quite a large college within the University of Glasgow. As you can see, we have significant staffing complement, over 5,000 students, and quite a strong track record of competitive research income, distributed across quite a wide range of intellectual domains that I'll come on to in a moment. We seem to be relatively competitive with regard to the outputs that we generate from the research that we do. Our clinical programs are quite highly ranked. In 2020, this undergraduate medical program, nursing program, and dental program were all ranked #1 in the UK, and this translates to relatively competitive places in the global rankings with which we're all familiar. Looking in a little more detail at the structure of the college, I should caveat this by saying that we're in the process of restructuring the college to make ourselves even more collegiate and better able to engage constructively and productively with colleagues across the world. But we have 3 schools, a School of Life Science, a School of Veterinary Medicine, and the School of Medicine, Dentistry and Nursing, which I'm proud to be in charge of. And we also have 7 research institutes spanning the areas where there are particular strengths within our university. And these predominantly are in cancer sciences, in cardiovascular, metabolic medicine, in One Health, animal health, in infection, inflammation, and immunity, and also in what we call health and well-being, which is more of a kind of public health domain, with a particular interest in health inequalities. So this is the structure, but we're a porous structure. We interact a lot with each other, and we interact externally very significantly. In terms of our major research beacons and the areas where we feel we have particular strength, the main ones that we have are in precision medicine and in management of chronic disease, in One Health, and also in addressing inequalities, particularly health-related inequalities in a clinical context. And we have quite significant research income that draws from the funders below and others. Looking in a little more detail to take an exemplar of our precision medicine work, we've got a major interest in both the basic science and the clinical manifestations of cancer, and particularly in pancreatic cancer, where we've been pioneering some of the really quite exciting work that's being done, looking at translating basic science advances in understanding into clinically meaningful advances in treatment. So the premise of our precision oncology therapeutic program is that if we can identify the specific genetic mutations that are driving the cancer, in this case, cancer of the pancreas, we can select specific therapies that target those mutations particularly, and in doing so, improve outcomes for patients. So this is a technology that's still in its infancy, but it's developing very rapidly, and it's an area that Glasgow is leading on under the guidance of Professor Andrew Biankin, whom we recruited from Sydney a few years ago. So we're doing some exciting work as an example in that area, moving away from the clinical paradigm that we use specific drugs to treat cancers depending on where in the body we find the lump. So if the lump's in the pancreas, these are the drugs we use for pancreatic cancer. We're now looking at the mutations in the cancer, looking at the biology of the tumor in far more detail than we used to, and making treatment decisions based on those parameters rather than the cruder ones that we'd used previously. Again, if we're talking about clinical advances and drawing together molecular and clinical technologies, this is a new building that just opened a year or so ago. It's called the Imaging Center of Excellence, and inside we have one of the very few 7 Tesla magnetic resonance scanning devices that are available on clinical sites. So this is co-located with our hospital, and this is a really exciting development for us because it allows us to use very high magnetic field strength imaging in order to look with better detail than ever before at various pathologies going on within the human body. So here's an example of magnetic resonance angiography. I'm a stroke specialist. This is actually the brain of my colleague, whom you can see here, looking in immense detail at the blood vessels of the brain. That will greatly enable us to prosecute more ambitious agendas of research and delivery of more advanced therapeutics. That's just one example of many enabling imaging techniques that are unlocked if we use very high magnetic field strength with 7 Tesla. You may, the more astute of you may recognize the back of this man's head. This is Tim Cook from Apple, who came to visit us a year or two ago as we opened that building, because Apple have got some interest in the application of artificial intelligence and high-end information technology to the processing of the sorts of high-resolution images we can acquire from 7 Tesla magnetic resonance scanning. So that's some of the sort of more forward-looking activities that we have in Glasgow. We're also a historic university, not quite as old as I mentioned as St Andrews, but we're very proud of our tradition in research and in education. So we've been teaching medicine here for about 400 years, and our alumni include Joseph Lister, who was the first to develop antisepsis and spraying carbolic acid onto the surgical sites of patients who are being operated on. And we still have a really strong interest in microbiology, infection control, and the development of novel antimicrobial compounds. Other historical areas, Ian Donald, an obstetrician who invented ultrasound. He adapted the principles that we used during the Second World War. He was a naval officer and was involved in using sonar to detect submarines under the sea. And he applied that same technology to clinical obstetric practice. And we have a really strong relationship with our biomedical engineers still at that really exciting interface between medical practice and basic science and engineering. So another area that we're keen to develop further. One of the things that's helped us particularly develop all of these ambitions is the development of this, the Queen Elizabeth University Hospital. This is where I'm talking to you from at the moment. It's the largest acute hospital in Europe. It has some fantastic laboratory facilities here. It has the Imaging Centre of Excellence that's just been built on this spot here. And we have a tremendous opportunity to do lots of clinical research because there are very high numbers of patients who obviously come through this building for treatment. Just finally, to emphasize the international nature of the work that we do, we're enormously keen to collaborate with colleagues right across the world. This was the first ever exchange of students, clinical medical students, with mainland China. This is from a few years ago, but we're very collaborative, and we enjoy identifying other institutions all across the world and working constructively and productively with them. So that's a brief summary of where we are just now. These slides have been put together in the space of about 20 minutes because, as I say, I'm stepping in for my colleagues, so I'm sure there's lots of stuff I haven't covered, but we can perhaps pick that up in the discussion. We're proud to be one of Europe's leading schools in clinical education, and we have a very strong life science portfolio. We have a global vision, I think it's important to emphasize that, and we'll be very keen to collaborate with higher education institutions in Lithuania and beyond. So that, I think, concludes all I have to say. Thank you very much indeed for listening.
Well, our thanks, Matthews, to you for being such flexible and being able to join us. Definitely, it is of high value to participants of this event not to move away, far away from Glasgow. Now we stop then with the next UK university, University of Strathclyde, and second attempt, Philip, to not only see you, but also with your presentation. Here we go. The floor is yours. Good to have you.
Thank you so much for the kind introduction. Also, a warm welcome again from Glasgow, from the University of Strathclyde, and specifically I'm based at the Pharmacy and Biomedical Sciences. Before we look at the institute I'm based at, I'll give you a brief overview of the University of Strathclyde. We're not quite as old as the University of Glasgow. We are 226 years old, and we are a leading technological university here in Glasgow. We are the third largest university with over 23,000 students from 100 countries, and over the past few years, we've invested $1 billion into our campus, which is now coming to conclusion. We have a technology innovation center which links research to industry and business, and our focus is on global engagement with international partnerships. And indeed, we are an award-winning university. Specifically, I'll be taking you on a journey of what we do here at my home institution, which is the Strathclyde Institute of Pharmacy and Biomedical Sciences. And we have a worldwide reputation on contributing to real solutions to global health problems. We're educating the next generation of healthcare professionals. On the UK rankings, we are the #2 in pharmacology and pharmacy, the #3 in biomedical sciences, and the #4 in biological sciences. Here at the Institute, we've got more than 1,500 undergrads, 340 taught postgrads, and in excess of 140 research students. We have strong partnerships with leading international universities. We have a number of degree programs here at SIBS, undergrad ranging from biochemistry to microbiology all the way to pharmacy, but of course also postgraduate taught subjects like the Masters in Advanced Biochemistry, Cancer Therapeutics, and a strong focus on pharmacy, again, pharmaceutical analysis and quality. Industry engagement is a key staple for SIBS, and you can see on the slide some of the industries we closely work with, industry which we partner with, and many of these are direct tier one partners for some of our research missions. I will allude to as I go through some of the later slides. Our research areas and expertise are subdivided. So we've got expertise in cellular molecular basis of disease, identifying new drugs and targets, looking at signaling pathways, and using technologies like gene trap, CRISPR technologies, and translating these, investigating, for example, brain damage and repair using stem cells, and of course, collaborating with clinicians, both local and further afield. Another area which we excel at is the discovery, formulation, and delivery of medicines. We've got an active drug discovery program, making new compounds and screening them. We formulate drugs, both new and old, and we've got formulation specialists embedded within our building, which you can see on this slide. We also have the Cancer Research UK Formulation Unit here, which is a dedicated facility to really translate cancer research into clinical trials. And of course, we excel at drug delivery, pharmaceutical sciences, and novel materials. Another aspect is pharmaceutical materials and manufacturing, and it's the CMAC. And I guide you to that webpage as shown there, which is a world-class facility about manufacturing medicines, today's medicines, but also future medicines. It has unique expertise across the whole breadth of pharmaceutical sciences, from crystallization to process development, formulations, digital twins, industry 4.0, and so on, and continuous processes. And part of CMAC are tier one partners as shown here. And through that partnership, we really train individuals who are highly sought after from industry. Another branch which we excel at is microbiology and industrial biotechnology. For example, drug discovery using microbes, microbiology, biochemistry, microbiology, genetics, and genomics. And in order to translate these research findings and to excel, we work closely with the Rapid Bioprocessing Prototyping Center. Now, this center is part of the Industrial Biotechnology Innovation Center, which is situated on our campus grounds. And within the Rapid Bioprocess Prototyping Center, we're able to really push technologies into industry, looking at new cell lines, new production methods, and really looking at, for example, mini scale-up and transfer. Now, last but not least, pharmacoepidemiology and healthcare is an active research area within my institution here. And it's all about health service research, about, for example, antimicrobial resistance, drug utilization and policy. And of course, that is important because we are looking at developing and implementing guidelines, stewardships, but also looking at service delivery modes and design and assessment of new healthcare technologies. For this, we work with a range of partners here in Scotland, NHS, and further afield. And on that note, I would like to thank you for your attention. I'll be happy to take questions during the discussion. Thank you.
Thank you, Philip, for your presentation. Definitely. Also, thank you for your patience
Sure,
and staying with us. That was really a pleasure to hear your presentation and University of Strathclyde. We still have two universities at this pitching session left. Both are Lithuanian, and we move on with Vytautas Magnus University, and we have on remote mode Saulius Mickevičius, professor and dean of the Faculty of Natural Sciences of Vytautas Magnus University. Saulius,
good afternoon for everybody. Do you hear me and see my slides?
Yes, we confirm that everything is in place. Please proceed.
Okay. Thank you very much. I would like to represent Vytautas Magnus University, a university in the second largest city of Lithuania, of Kaunas, and mostly focus about the studies in research in life and related sciences, which are presented at the Faculty of Natural Sciences. Shortly, I will tell about our university. I am impressed about the ages of universities of the United Kingdom. Our university is not so old as our partners from UK, but nevertheless, this year is very important for Vytautas Magnus University. We are celebrating 100 years anniversary, and now we have 11 faculties in 2 cities. Major of our studies are in Kaunas, but we have some studies in campus in Vilnius too, and we have all fields of studies except the medicine, and we have arts, sciences, in informatics, humanities, social sciences, and music and education and agriculture studies. And now we have about 8,500 students, and about 10% of them are international students, and we have many study programs who are taught in English for full-time international students. I just talk about the study programs of Faculty of Natural Sciences, and if we look at the bachelor level study programs, we have 4 of them. It's biology and genetics, biotechnology, environmental sciences, and biochemistry, and 3 of them are prepared to teach for international students from us a full study programs. In the master level, we have 6 master level study programs: molecular biology and biotechnology, applied biotechnology, environmental management, biochemical analysis, biotechnology and pharmaceutical analysis, and industrial ecology. And 3 of them also are taught in both languages, in English and Lithuanian. And we have 4 PhD study areas. It is biology, ecology and environmental sciences, biophysics, and biochemistry. I will shortly present our research priorities. In our researchers are working in fields related with environmental changes and climate effect of alive organisms, on ticks and tick-borne diseases. They do research on delivery of medicine and genes, of instrumental analysis methods, in biophysics for bio-nanotechnology and biomedicine, and molecular bioenergetics. We have 6 research clusters working in the fields of life and related sciences. And then we are working on international projects. Most success and most famous of them, we now have 3 projects of program Horizon 2020. Also, we are very active in the local projects. We have 4 projects from Lithuanian Research Council. We have Lithuanian Japan program, projects from that program. We also are quite good collaboration in the projects together with business partners, and we had 8 projects of research and innovations together with business partners, and we have some small scale projects which are coming from business. They asking to do us some type of research. And I also would like to present the achievements of our professors of the Faculty of Natural Sciences. It's a great pleasure to have Lithuanian Science Award winners in the field of biomedicine and agricultural sciences for the cycle of work effects of urban environment, physiological and epigenetics factors of health from infancy to maturity. And it is the Lithuanian Science Award from the last year, 2021. And we have the member of Lithuanian Academy of Sciences. We have laureate of local Lithuanian award of Lithuanian Academy of Sciences in the field of biology. And we also are very proud of our alumni who are working around the world, and they are working in UK and USA as well. So probably the most known our alumni of our faculty is Professor Skirmantas Kriučionis, and he has his own group in Ludwig Institute of Cancer Research at University of Oxford. And we also have notable alumni working in USA. It's Dr. Artūras Žeimys, working in Department of Nanomedicine, Houston Methodist Research Institute. Dr. Tomas Drevinskas, he is a NASA postdoctoral program fellow at Jet Propulsion Laboratory in Caltech. And Dr. Mantas Šilkūnas and his wife, Dr. Giedrė Šilkūnienė, they are working as researchers in Old Dominion University in Norfolk, Virginia, United States. I just shortly tell about the main areas and the main achievements of which are coming from our faculty, and I will be happy to answer to your questions, and I will be happy to have more collaboration with the UK universities. Thank you very much for attention, and looking forward for the future collaboration, and looking forward for your questions. Thank you.
Yes, thank you, Saulius, for making yourself present, making your presentation. Definitely we will look for these collaborations to facilitate. And the last on the university pitch session, we have Vilnius Tech University and Vaidotas Vaišis, Director of Science and Research Office. Good day, Vaidotas, and we can see you and hope that the other arrangements are in place. Yes, we can see the slides, please. So the floor is yours.
Good afternoon. Good afternoon. So, as you may see, Vilnius Gediminas Technical University is actually the largest potential and mainly lies in technological fields. And we do have 10 faculties, and priority research areas are sustainable building, environmental and energy technologies, sustainable transport, mechatronics, information, economics, fundamental research of materials and processes, but especially in interdisciplinary cases such as research fields like materials, nanostructures, bionics and biomedical engineering systems, cells, biology, active compounds, mathematical models are the areas in directly related to life sciences. And here, the most actual and key interesting ones I would like to point today. So applied bioelectromagnetics and electroporation based technologies. In this research topic, we are working either in silico, in vitro, and in vivo. And in this topic, main research topics and potential lines in wound sterilization, cancer treatment, food processing, non-viral transfection and DNA transfer, simulation of cells, development of power electronics for biomedical applications, and the achieved results are either publications, 5 PhD thesis defended, and collaborations more than in 10 national and international laboratories. Together, this topic is implemented in 3 national and 2 international projects. And what is quite important, as I do mention, as we are from the technical side more, it's 10 pulsed power prototypes and devices for this particular area. Another topic is clinical decision support systems towards medicine 4.0, and in this topic mainly potential lines in the feedback, measurements, movement analysis, biomechanical models, especially for the active healthy aging, artificial intelligence-based technologies for data processing, and markerless motion detection for classification, biofeedback technologies, and so on. This topic is covered by 3 PhD thesis defended. 3 students are currently working on this topic, and we do have ongoing research project in this topic within EU funding. Another topic, mechanics of ultrafine object. This topic actually more relates with the simulation things, and the main research topics and potential is in simulation of interaction of ultrafine particles, droplets, interactions of cells, viruses, molecular interactions, and is achieved in the certain amount of publications, 1 PhD student, and international project within the Technical University of Berlin. Another topic is next generation sequencing to monitor the microbiological community composition and dynamics. And in this topic, potential lies in DNA isolation, next generation sequencing, and data analysis. The same topic is covered by human resources and participation in national and international scientific research projects. Topic of metabolism of the modified heterocyclic based on tRNA. Main research topics and potential lies in new genes, search in environmental samples, isolating and characterization of the corresponding proteins, and the same topic is covered by human resources and national scientific research project, which starts this year. So very briefly, because it's quite complicated to be the last presenter, but any kind of interest, any kind of request, questions, and other things like that could be directly sent to my email, and I will really find the proper researcher from our side for the best cooperation with your universities. Thank you very much.
Well, Vaidotas, thank you. Being the last not necessarily means the least of interest. So in any case, this session with small disturbing details went through, and I'm happy to know that all universities who have been planned, they were present, they were delivering their utmost effort in presenting themselves. Thank you indeed, everyone. And taking into account that we are slightly behind the schedule, I don't know when the word slightly is relevant, but I would say 15 minutes behind the schedule would fall in this case within slightly, and your patience is still present. We would not do a break and we would proceed without it forward, just to value your time ahead. And we do have now, after the university pitch session, 2 speakers from UK, and I hope they are with us. And we would start with Joe Frost, UK National Contact Point for Horizon, Europe Health Funding and Global Innovation Lead, Health and Innovative UK Research and Innovation. Yes, Joe, I am pleased to welcome you, and then the floor goes to you.
Okay, brilliant. Hopefully you can hear me okay. Oh, and my slides are up. Oh, that's good.
Always good.
Great. So I'm going to explain to you about the Horizon Europe programme and explain how UK organisations can participate and collaborate with those in Lithuania. So I want to start by explaining what national contact points are. So national contact points are free help desks that can support applicants to Horizon Europe. There's a network of national contact points in Lithuania, in the UK, also in EU member states and beyond that as well. And the services can vary, but typically they include informing and awareness raising, assistance, advice and training, and signposting. So you can contact the national contact points with any queries you have. And at the bottom of the slide, you can see on the left the 3 Lithuanian health NCPs for health, and then I'm on the right. You can connect with me on LinkedIn and Twitter if you want, once you get the slides. And at the bottom right, we also have UK newsletters on Horizon Europe, including health. So you're welcome to sign up to those if you want to. So now I'll introduce you to Horizon Europe. So the EU funds research and innovation through its framework programmes, which run for 7 years. And the previous programme called Horizon 2020 finished recently. And the current programme, Horizon Europe, started last year and will run until 2027 with a budget of at least 95.5 billion euros. There are documents called the work programmes, and they list the individual core topics that you can apply for, and the 2021 and 2022 work programmes have been published already. We don't know in detail yet publicly the core topics from 2023 to 2027. As you can see at the bottom of the slide, the UK and the EU have agreed that the UK will associate Horizon Europe, which means that those organisations and researchers based in the UK will be able to take part in projects, which is very good news. So just to run through how association works in a bit more detail, UK entities will have the same rights to participate in projects as EU member states. There's only 2 rare exceptions, which you can see on the slide. One is the equity fund part of the European Innovation Council Accelerator, where the UK decided not to take part. And secondly, occasionally for individual core topics, there might be an exclusion in the work programme, but I'm not aware of any cases of that related to health. As you can see in green, UK entities can lead projects as coordinators, and also UK experts can take part in peer review. If anyone from any country wants to register to be a peer reviewer, that's quite a good way to learn what makes a good proposal, and the link's on the slide. So the European Commission has published a Q&A on the UK's participation in Horizon Europe, and I put some quotes from it there. The UK is expected to become an associated country to Horizon Europe. The UK will have the same rights and obligations as other countries associated to the programme, and the association has already been agreed. There's no additional negotiation foreseen, but it hasn't actually been signed. So we hope that the association will be signed and adopted soon. UK applicants are treated as an associated country throughout the process, from the submission of the proposals and during evaluation and up until the grant agreements signed already. So if you're working together on a proposal, the UK needs to be listed on your proposal as an associated country. And the funding rates and terms and conditions are pretty much the same for UK organisations as other countries. At the bottom of the slide, you can see that associated countries concept is not new. There was 16 associated countries in the previous programme, including countries like Israel, Norway and Turkey. And there's a link to a document which tells you which countries are already associated to Horizon Europe and which countries are in the process of doing so, like the UK. In the longer term, the EU has already started discussions with some countries like Canada, South Korea, Japan and Australia, which haven't been involved in the past as associated countries, but are interested in potentially exploring becoming associated. So the list of associated countries might increase or change over the next few years. So if you're not familiar with Horizon Europe, this is a key slide. This is the structure of Horizon Europe. It is formed of 3 pillars. On the left, you've got the European Research Council, which is open to any areas of research and funds cutting-edge projects for a principal investigator and their team. Under that, you've got Marie Sklodowska-Curie actions. These are also open to any area of research. And this part of Horizon Europe funds individual fellowships, training networks for doctoral students, and has a staff exchange scheme and a co-funding scheme for fellowships and things as well. The final part of the left pillar is Research Infrastructures Funding Programme, and that contains a number of core topics related to health as well. In the middle pillar is the main thematic or top-down part of Horizon Europe, and it includes 6 different themes, which are the bullet points there, which are known as clusters. And there are health topics in most of them, but the main place with the health topics, not surprisingly, is the first bullet point, which is the Health Work Programme or Health Cluster. So I'll explain to you a bit more what's in that. So the health cluster had 6 sub-areas, which you can see on the left of the slide. The first one is staying healthy in a rapidly changing society. And this includes things like funding for research on aging, mental health and AI. The second sub-area is living and working in a health-promoting environment. And this includes topics like pollution, urbanisation, climate change and social economic inequalities. The third is tackling diseases and reducing disease burden, which includes diagnostics, advanced therapies, infectious diseases, and health technologies. The fourth area is about healthcare, and this includes topics related to governance, finance, resourcing in healthcare, as well as patient empowerment. The fifth area is new tools and technologies and digital solutions for a healthy society, which includes safety, ethical, legal, and regulatory issues. And the final area at the bottom is an innovative and sustainable, globally competitive health industry. And this includes market access for innovative tech, including medical, pharmaceutical, biotech, and digital tech, and also topics on creating greener pharmaceuticals and technologies. At the top right of the slide is a link to the 2021 to 22 work programme. Lots of these cool topics have already closed, and the last one shut in April. So you'll have to be very quick if you're not already involved in a proposal and you want to get involved in one of them. But you can speak to your national contact point. Probably more interestingly, if you're new to this, is that the new work programme for the 2023 and 2024 core topics will probably come out at the earliest in late spring, so maybe June or July at the earliest, and that will contain all the core topics for the next 2 years using 23 and 24's money. And if you sign up to our newsletter, we'll let you know once this has been published. There's also likely to be information days and partnering events once that work programme has been published. I put another slide in, which is just a screen print of a commission slide. The main reason I put it in is I wanted to show you the graph which shows the number of partners in the previous programme in the project. So typically projects had 7 to 18 participants or organisations, as you can see in bold in the middle of the slide, with 13 in average. For most of the core topics, the minimum is having 3 different countries involved, but normally the projects are bigger than that. So in the health part of the programme, for nearly all the core topics, they're kind of consortia projects involving various countries that are member states and associated countries. Also, you can get funding to work with 122 low and middle income countries outside Europe. And one special thing in the health theme is you can also get funding to work with US organisations. They'll be funded in the health part of Horizon Europe, but not in the other parts of Horizon Europe. I just finally wanted to briefly mention something called the Cancer Mission. So this is kind of like a separate pot of funding, and as you can see on the slide, it hopes to address three challenges, which is that 2.7 million people in the EU are diagnosed with cancer each year, and 1.3 million people unfortunately lose their lives each year. So the goal of the cancer mission is in the box in the middle of the slide, which is to improve the lives of more than 3 million people through prevention, cure, and also support for individuals and their families affected by cancer, hoping to give them longer and better lives. The EU also has a beating cancer plan, and the mission and the cancer plan kind of sit next to each other. As you can see in the blue box, the cancer mission has 4 objectives: understanding cancer, prevention and early detection, diagnosis, treatment, and quality of life. And some of the actions that the EU is taking are in the other blue box on the right, which includes providing 378 million in the first few years of Horizon Europe for calls related to the cancer mission. Those are in a separate missions work programme, they're not in the main health work programme. They've also set up something called UNCAN, which is Understanding Cancer online platform, and they're going to set up a patient digital centre and a network of comprehensive cancer infrastructures. The bottom bit of the slide in orange explains a bit what the Commission mean by missions, but basically they want to take a bold step forward, and they refer to kind of the moonshot when the US went to the moon in terms of lots of progress. So my final slide with any content on really is just this list, which has the 3 topics that are open for the cancer mission in the middle of the slide. Those shut in April, near the end of April as well. So again, if you want to apply for those, you'd have to get going pretty quickly. So there's developing new methods and technologies for cancer screening and early detection. The second topic is to develop and validate a set of quality of life and patient preference measures for cancer patients and survivors. And the final topic that's open at the moment is the better understanding of the impact of risk factors and health determinants on the development and progression of cancer. In the slide pack that I guess will be available to you afterwards, there is one further slide with more links for the cancer mission, including some info on people looking for partners and things like that. So the best thing to do is, if you want to, you can sign up to our newsletter and stay up to date with future calls, and you can talk to your national contact points in the UK or Lithuania if you have any follow-up questions. That's it from me. Thank you.
Well, thank you, Joe, for this informative slides, and I think that's going to be of interest to a number of universities and the researchers groups. We have your colleague also, Caroline Johnson, Program Manager for Bacteriology, Microbiology, Antimicrobial Resistance, Infections and Immunity Board, Medical Research Council, part of UK Research and Innovation, and she'll talk about funding opportunities for transnational cooperation. Caroline, you are a closing speaker for our today's webinar, but good to have you. Please do your best to make participants engaged. It's always a challenge, but pleasure is ours.
Well, thank you so much for having me. And yeah, hi everyone. I hope you're all well and you've all enjoyed this fantastic event, despite the awful things that are going on in Ukraine. So just to really briefly introduce myself, I'm Caroline Johnson. I'm a Programme Manager for the UK Medical Research Council, and I'm here to give you a really short tour of some of the options out there for funding collaborative research between the UK and Lithuania. So I'll just give you a quick background to the MRC. The MRC is a government-funded research funding organisation, and we're part of a much larger whole, which is UK Research and Innovation, which incorporates all 7 research councils and Innovate UK, who we just heard from with the wonderful Joe. And Innovate are our innovation funder. And then finally, we also have Research England, who fund our universities, or some things for universities. The MRC itself funds medical research, as the name suggests, and we fund from basic science up to stage 2 clinical trials. Other research fields are covered by the other research councils, so things like biology and biotechnology are covered by BBSRC, and environmental science by NERC. Not all of the councils allow international co-investigators, so it's always worth checking with the relevant council before you start thinking about putting together an application. So I'm just going to give you a brief talk about 4 different options for collaborative research involving both UK and Lithuanian researchers. So the Global Alliance for Chronic Disease, the Human Frontier Science Programme, obviously the joint programme initiatives, which you heard a little bit about before from Živlė, and I'm going to talk more in detail about standard MRC response mode funding. So just to give you a bit of background about the Global Alliance for Chronic Diseases, this brings together major international research funding agencies to address the growing burden of non-communicable disease in lower and middle income countries and vulnerable populations in high income countries. So they invest in impactful NCD implementation research, they build implementation science capacity and capability in relation to NCDs, and they try to facilitate collaborations and partnerships to support investment and impact. They have a call out at the moment, which is entitled The Life Course Approach to Common NCD Risk Factor Prevention and Reduction. And this closes on the 31st of May 2022. So rather like some of the things that Joe was talking about, you probably want to get your skates on if you want to apply for anything from them. So the next sort of opportunity I wanted to talk about is the Human Frontier Science Programme. So these grants support innovative basic research into fundamental biological problems, and they have an emphasis on novel and interdisciplinary approaches that involve scientific exchanges across national and disciplinary boundaries. So they're really aiming for interdisciplinary approaches, thinking things like biophysics, chemistry, computational biology. Research grants are provided for teams of scientists from different countries who wish to combine their expertise in innovative approaches to answer questions that couldn't be answered by individual laboratories. They offer 2 kinds of grants. They offer early research grants, early career research grants, and program grants for more established researchers. And the latest call requires submission of a letter of intent by March the 24th, which I think is 2 weeks' time. So you would have to be hurrying for that. But they do obviously have regular calls. And the only thing to really think about with this, the principal applicant of any research grant must be from one of the member countries, which does include both Lithuania and the UK at the moment. But the other team members may be from anywhere in the world, as long as the teams fulfill the basic international requirements. And then for the early career grants, young scientists from anywhere in the world can apply for a fellowship to work in a laboratory of one of the supporting countries. So scientists from one of the member countries can apply to work anywhere in the world. Then I'm just going to briefly cover the JPIs. So I know Živlė mentioned these earlier. I'm just going to reiterate that a number of JPIs are open to UK and Lithuania collaborations, and really to remark that the JPI EOMR network call is open now. So do have a look if you've got an interest in antimicrobial resistance. Finally, I'm going to talk about sort of my real area of expertise. So MRC funds international co-investigators as standard practice. And this is as long as the inclusion of that researcher is adequately justified. So justification would mean that they would provide skills, data, or access to samples that can't be found in the UK. So for these applications, the lead investigator must still be a UK-based researcher, but you could obviously have a Lithuanian co-investigator on any kind of grant for the MRC. The funding is a little bit different. So for Lithuania, MRC would fund 100% of the direct costs for the Lithuanian co-investigator. So these things like salary and consumables, but the MRC won't fund indirect and estate costs for researchers in developed countries like Lithuania. And in these countries, costs must not be more than 30% of the 100% value of the grant. So if you're planning to put in an application with international co-investigators, you should really contact the relevant program manager in the MRC at the first instance, so they can both approve the costs and take you through the process and make sure that you understand exactly what's going on. So yeah, I'd just like to thank the organisers for inviting me, and thank you all for listening. And if you have any questions after the event, please just get in touch with me. Thank you.
Thank you, Caroline, for your presentation. Once again, we are at exactly 4 p.m. Lithuanian time, 2 p.m. in UK. As planned, it should be a concluding part of our event. I know that we were supposed to have a question and answers session, but there were a number of responses throughout the platform. A couple of questions were of more specific nature. To some of them I will very quickly, as a moderator, will reply. One question was about possibility to use Erasmus Plus instrument for UK and Lithuanian partnerships. No, it is not possible, but there was a question that some from Lithuanian side would like to invite a number of Oxford University partners. So in UK there is a new program to replace Erasmus Plus called Turing scheme. They do have funding for their students, their academicians to be sent. So you need to dig deeper into it if that would be of interest. And I think for our universities, if to keep up the relationship after post-Brexit context, Turing is one of the options. Then I would like, as a concluding part, to make a few points. First of all, after this event, there will be some follow-up projects or concrete developments in life sciences. With the Cormac Consultancy being involved, we are planning with all major Lithuanian universities and also involving UK universities to launch a talent attraction project, 1,000 foreign students to study at dual degree programs in major universities in Lithuania in partnership with UK. This spring we will come back on this, but Lithuanian universities are already informed and we are working with a finalization on it with the Ministry of Economy and Innovation and Ministry of Education to support it. Then, as you saw today, there were major Lithuanian universities, in fact all 7 universities who have activities within the field of life sciences, but on the other side we might have much bigger presence from UK universities, but in this case we have approached a number of universities. We asked them to jump in with their presentations. The ones who were responding were today present, but it is perfectly fine, and the instruments through Horizon or other should be used to keep partnerships with other British universities, and we saw from some presentations that these contacts, projects, partnerships are ongoing, and that's just excellent news to see fuller picture. Practical things. All presentations will be distributed to not only presenters and the speakers among themselves, but to all participants. We'll do our best that without big delay you would have it all. Good news is that the interest from participants was quite high. At the end of the event, there were at least 60 online participants still present. And I think with the more than 3-hour event, that's already an achievement. And that is to salute the speakers who made this event meaningful. And of course, I would like to thank all participants who have expressed interest and joined this event as well. And of course, my final thanks goes to hosts, Research Council of Lithuania and the team in helping to arrange that. Of course, Migle and the Ambassador and the British Embassy in Vilnius for taking this initiative up. Once again, thanks a lot to everyone and also for the technical team which made that all planned speakers would be with us today. Thanks a lot, and we will do our best to keep all the follow-up initiatives if needed, including our organization. We are keeping up these partnerships. We are helping them not to disperse at the initial stage, so we'll be happy to follow up in every individual case. Thank you, everyone. Ačiū labai visiems.